channel. It's been a while. Accept my apologies, I've been damn busy, but I'll try to be consistent now. If you are just joining us, welcome. I am Akanibo Abimbola, also known as Abimboli. If you haven't subscribed yet, please subscribe, and don't forget to turn on the notification button to get notified whenever I post a new video. Today I'll be completing my last video on separation techniques. I'll be explaining in full details all the separation techniques I mentioned in my last video. So stay tuned and let's go. Crystallization is used to produce solid crystals or a heat-liable solid from a solution. When the solution is heated, it becomes a saturated solution, and some of the solvent evaporates, leaving behind a more concentrated solution. The difference between a saturated solution and concentrated solution is that a saturated solution is a solution that contains the maximum, that is the highest amount of solutes, that is solids that are soluble in liquids, which can dissolve in a given volume of solvent at a particular temperature, while a concentrated solution is a solution that contains lots of solutes dissolved in it. Crystallization is a technique used for the purification of substances. It is a separation technique to separate soluble solids from a solution. When we add a solute, that is a soluble solid, in a liquid at a given temperature and stir it continuously, the solid dissolves in the fluid. But when we add more and more solutes in the liquid solvent, a point comes after which no more solute dissolves in the liquid. This point is called the saturation point, and the solution becomes a saturated solution. Crystallization process. The solution is heated in an open container. The solvent molecules start evaporating, leaving behind the solutes. When the solution cools, crystals of solute start accumulating on the surface of the solution. The size of the crystals formed during this process depends on the cooling rate. A large number of tiny crystals are formed if the solution is cooled at a fast rate, while large crystals are formed at slow cooling rate. For further separation, another separation technique called filtration is used, as seen in the diagram, to separate undissolved solids, that is, crystals in the liquid. And that will be the next separation techniques I will be talking about. But before that, let's talk on experiment to understand crystallization. Experiment to understand crystallization. Take 50 milliliter water in a beaker. Add sugar in it and stir it. Now heat the solution. Repeat the process continuously. After some time, there will be a point at which no more sugar can be dissolved in water. This stage is the saturation point, and the solution is referred to as saturated solution, as I mentioned earlier. Now, filter the sugar with the help of a filter paper. Collect the filtrate in a gas bowl and cool it. We will observe that some fine crystals are formed in the bowl. The process of filtration can separate these crystals. The liquid left after the removal of crystals is known as the mother liquor. Application of crystallization. Crystallization can be applied in purification of seawater, separation of alum crystals from impure samples, in the pharmaceutical industry. Crystallization is used as a separation and purification process for the synthesis and isolation of co-crystals, pure active pharmaceutical ingredients (API), controlled release pulmonary drug delivery, and separation of chiral isomers. The art of filtration was known to early humans, who obtained clear or pure water from a muddy river by scooping or digging a hole in the sand on a river bank to a depth below the river water level. That is, early humans will dig the sand by the river bank, which is the sand surrounding the river, to the same level with the bottom of the river. After this, water will pass through the sand into the hole, leaving the mud in the river. The same process on a larger scale is commonly used to purify water for cities, but also refined. Filtration is therefore the process of separating suspended solid matters, that is, solid particles that does not dissolve in liquid or gas in a liquid or gaseous fluid, by causing the latter, that is, the liquid or gaseous particles, to pass through the pores or holes of some substances called a filter. The liquid or gas fluid or particles which has passed through the filter is called the filtrate. The latter, that is the clarified liquid or gaseous particles, or the solid particles, that is filtrate removed from the fluid, may be the desired product, that is the product needed. In this, I will be explaining the three related separation techniques together, which is decantation, separating funnel method, and loading. We all have seen our mothers separating stones and husk from rice in the kitchen. These visible impurities, stones and husks, are easily removed by hand picking. But what do they do for smaller impurities, that is dirt like mud and dust? We notice that water is poured in the vessel and the upper layer of dirty water is discarded, that is poured away gently, leaving the pure rice in the container. Decantation is therefore the process of separating of liquid from solids and other immiscible, that is non-mixing liquids, by removing the liquid layer at the top from the layer of solid or the immiscible liquid below. When we say separation of liquids from immiscible liquids, an example is mixture of oil and water. These both don't mix, but instead separate into two layers, where water goes down and oil, being lighter, goes up. We can remove the oil layer from the mixture by gently pouring it into another vessel, leaving the water layer at the bottom. Most of the time, this process is not very efficient in this separation because thin layer of the remaining oil is still left in the water mixture. In order to make it efficient, we use a separating funnel method as shown in the diagram. In this method, the bottom layer, which is the water layer, is collected first, and the layer above it, which is the oil, is made to remain in the vessel with the help of a stopcock, and this can also be poured into another vessel separately. This separation technique is very efficient if we are dealing with particles that settles easily, but when we are dealing with particles that doesn't settle easily, like mixture of water and mud, we apply the separation technique called loading. Loading is the process by which the mixture of liquids containing tiny particles or impurities is separated by adding a chemical that sticks to the impurities, making them heavy and settle easily, leaving the liquids up. The process of loading is always followed by decantation or separating funnel method in this case. Example, in our homes at times, we fetch water from the well and found it to be moldy. What we do is add alum, which is the chemical, and after some time we observe that a layer of mud settles at the bottom of the vessel and water becomes clear. What happened was that the alum got adhered to small mud particles and made it heavier, causing the mud to settle at the bottom. And what we do next is gently pour the clear water into another container, leaving the solid mud, which is decantation process. Sublimation is a process whereby a solid substance changes directly into its vapor without passing through liquid state when heated. Example is camphor and ammonium chloride solid and iodine. Sublimation is used to separate the mixture of two solids whereby one can sublime when heated. Example is the mixture of ammonium chloride and sodium chloride. The mixture is placed in a test tube and then heated. Ammonium chloride vaporizes, that is, sublimes into vapor. When the vapor of ammonium chloride reaches a cool region, it condenses and turns back into ammonium chloride solid. Evaporation is the process whereby liquids changes into gas in the presence of heat. Evaporation can be used as a separation method to separate components of a mixture of dissolved solid in a liquid. When the mixture is heated, the liquid evaporates, that is, converts from liquid state to gaseous state. When the liquid is completely evaporated, the solids are left behind. Process of evaporation: dissolve solute or solid in liquid or solvent. Heat the mixture in a evaporating basin. Allow the hot solution to cool. The solid left appears as a pure crystal. Filter cold crystals. Simple distillation is a procedure by which two mixable liquids with different boiling points can be separated. Simple distillation can be used effectively to separate liquids that have at least 50 degrees difference in their boiling point. Distillation is the process of separating constituents of a liquid mixture by vaporizing and then condensing the vapor into liquid. Distillation is probably the most common technique for purifying organic liquids. In simple distillation, a liquid is boiled and the vapors progress through the apparatus until they reach the condenser, where they are cooled and reliquefied. Liquids are separated based upon their difference in boiling point. There are certain things to note when setting up distillation apparatus. 1. The tip of the thermometer must be correctly positioned slightly below the center of the condenser to accurately reflect the temperature of the vapors as shown in the diagram. 2. The water supply should be connected to the lower part in the condenser and the drainage tube connected to the upper as shown in the diagram. 3. Also be sure to use the thin wall tubing and not heavy wall vacuum tubing. Be very careful that your water lines do not come in direct contact with your hot plate, as the tubing could melt, resulting in a flood. Be sure to clamp both the round bottom boiling flask and the collection flask. Fractional distillation is used to separate more than two mixable liquids with close boiling points, like the components of crude oil as shown in the diagram. The step-by-step process will be explained under the topic in chemistry called petroleum. Fractional distillation is also used in the liquefied air, which separates air into its fractions. The difference between the setup of simple distillation and fractional distillation is the fractionating column, which contains small bits. The separation of fraction is carried out in the fractionating column. The bits in the fractionating column will condense the vapor of the liquid which has not reached its boiling point back into the round bottom flask that contains the mixture. Chromatography is a method used by scientists for separating organic and inorganic compounds so that they can be analyzed and studied. Chromatography is therefore an important biophysical technique that enables the separation, identification and purification of the components of a mixture for qualitative and quantitative analysis. The Russian botanist Michael Sweat coined the term chromatography in 1906. The first analytical use of chromatography was described by James and Martin in 1952 for use of gas chromatography for the analysis of fatty acid mixtures. A wide range of chromatographic procedures makes use of differences in size, binding affinities, charge and other properties to separate materials. Chromatography is a powerful separation tool that is used in all branches of science, and it's often the only means of separating components from complex mixture. Chromatography has numerous applications in biological and chemical fields. It is widely used in biochemical research for the separation and identification of chemical compounds of biological origin. In petroleum industry, the technique is used to analyze complex mixtures of hydrocarbon. Centrifugation is a technique which involves the application of centrifugal force to separate substances of different densities, as in milk and cream, with the use of an apparatus called centrifuge. Centrifugation is used to separate components of heterogeneous mixtures, which can be liquid in liquid, or solid in liquid, or solids and liquids in gases. Centrifugation uses centrifugal force to move dense components to the outside of the container, and at the same time objects that are less dense are displaced and moved to the center. Precipitation is a technique used to separate a mixture based on the solubility of its components. The solubility of a compound depends on the ionic strength of the solution, its pH, and the temperature. Manipulation of these factors can cause a compound to become an insoluble solid and fall out of solution. Precipitation is the creation of a solid from a solution when the reaction occurs in a liquid solution. The solid formed is called the precipitate. Example: if silver nitrate solution is poured into a solution of sodium chloride, a chemical reaction occurs, forming a white precipitate of silver chloride. Thanks so much for watching my video. Feel free to leave your comments and ask any question you don't understand. If you haven't subscribed yet, please subscribe, and don't forget to turn on the notification button to get notified whenever I post a new video. And don't forget to give this video a thumbs up and share with friends and families. My next video will be my first edition of story time, so stay tuned and don't miss it out. Thank you. See you next time. Bye bye.